All right. So today what I wanted to go over was a little bit more of object-oriented programming and how different objects can interact with each other. So this is going to be kind of tutorial based, and I'm going to talk through what I'm doing and talk about what's going on there, and then I'll answer questions at the end. But we're going to go ahead and we're going to focus on two classes today. I want to focus on a person class and a team class. And the person class will be um, a data class that just holds data about a person. It'll be real simple. Everything on it will be just like an integer or a string data type, all primitive data types. Well, string is not primitive, but all just basic data types that we're used to. On the team, we're going to have a list of person. And so we'll get to see how the classes can interact with each other like that. And that's kind of the point of object-oriented programming. In life, we look at everything, we think of everything as objects. If you think about like a DVD player, it has properties such as weight, length, depth, height, color. Those are all properties, attributes that define that object. And then it also has functionality or methods like play, where it starts playing the DVD, or rewind, or whatever else is on a DVD player. All objects have attributes that define them, and then methods or functionality that they can perform. And object-oriented programming takes that idea and wraps it into programming so we can use the way that we think in life in our code. So that's what we're going to do here. We're going to create like I said, a person class, and we'll have some attributes or some properties and methods on that person class that define the person. And then we will have a team class, which will have some attributes, one of them being a list of person, or grammatically speaking, a list of people. We'll get to that. So I've created a new console application here. It comes out with the default hello world. I'm going to leave that for now. And I'm going to go ahead and come over here and add a new item. It's going to be a class, and I'm going to change the name down here to person. In C#, the naming convention for a class is that it's usually Pascal case. So the first letter should be capitalized, and every first letter of a proceeding word should be capitalized as well. So if it was like person, if it were like race car, even though that's really one word, but let's do customer bill. You would use Pascal case like that. So we're going to stick with person for now. Create that new class, and here it is. So let's go ahead and I'm going to create some private properties up here, some private fields. I'm going to call this one name, so it'll be a string, name, like that. Private int age, and we'll leave it at that for now. Now, in order to set these private fields, they can only be accessed inside of this class. So that means we need a way from outside the class to set these when we're instantiating an instance of this class. So when we're creating an object, we want to define what the name and age of the person are. So to do that, we need to use a constructor. So the syntax for a constructor is public, and then it's the exact same as the name of the class. So public person, and then we'll add our parameters here. There's going to be a string of name and an int of age. So anytime we create an instance of this class and pass in name and age, this constructor will get called. So when this class is getting initialized, this is what anything inside this code block here is what's going to happen. So let's say we want to be able to set our name and age on that object. Notice that this name and this age are not the same as this name and this age. These are just the parameters. The scope is only right here. So when it gets passed in, we want to capture it. So we'll say this.name equals name. Now watch when I highlight name, how it highlights name up here as well. So you can see that these are the same variable here. The argument that gets passed into this parameter, this is the parameter variable. When I highlight this dot name, it highlights the one up here, the property or the field of my class. So you can see by that highlighting relationship that this dot name equals name, remember single equals is our assignment operator, is assigning the value of the name passed in here to our name property or name field on the class. This dot age equals age, same thing. Anywhere from inside your class you say this dot, that is going to refer to the instance of that variable on the class or that specific object. So if I have 3 different persons instantiated from this person class, then this dot name inside person 1 will be the name of person 1. This dot name inside person 2 will be the name of person 2. This dot name inside person 3 will be the name on person 3. So now that we have that, we're going to add one last thing here. We're going to add a method. We'll say this is a public method, so we can call it from outside of the class. Public, let's make it void, and we'll say it will describe person. And we'll just call it describe because it's on the person class, so there's really no need to be redundant there. So describe. This will go ahead and console.writeLine, and we'll say name. Now I don't have to say this dot name because there's no other name inside the scope to conflict with it. If there was another name, I'd say this dot name. Name plus is blank is age years old. So that will describe our person. So if I come back to my main method in the program, I'll go ahead and delete this, and then I'll add my console.readLine in order to keep our console open while we're coding. Put that down a few there. We'll go ahead and create a new instance of the person class. Now, because the person class is right here in the same directory level as program, we have access to it right there, and it's inside the same namespace. So I'm going to go ahead and say person. We'll go ahead and call this person1 equals new person. Now, see when I put the parentheses there, that automatically shows me the method signature. So the constructor takes a string name and an int age, which is really useful so I don't have to be switching back and forth. So I'm going to pass in a string literal of Tom, and the age is going to be 29. So there's my person. You can see the syntax of declaring a new instance of an object from a class is you call the class name, so this is the type. Just like when we create a string, this is of type person. Here's the variable name. Person1 is a person, and then we're assigning to it a new object. This is what creates the object. If we just close it off like this, then this would be null for now. But we don't want it to be null. We want it to actually point to an object in memory, an object on the heap. That's this right here. Now to show that it works, we can say person1 dot. When I add dot, the Microsoft IntelliSense automatically shows me the methods on it. Describe is the one that I added. Go ahead and call that method. We'll run our program and see what happens. There we go. So it did describe person one. Person one is Tom. Tom is 29 years old. So there's our first person. Now, we can create a lot of, we can create more people. So let's go ahead and create person 2 equals new person, Sally. She is age 33. I can describe person 2. right? And we can start adding more and more. And this gets to the point where we might start thinking about arrays or a list, because we don't want to declare a bunch of different people. We might just want to store these in a list of person. So if that's the case, we could refactor this and we could create a list of type person. Anytime you have this greater than, less than, that is a generic. It's called a diamond operator. So whatever you pass in there, you're saying this collection, this list, is a list of this type. This could be string, int, it could be anything. So this is a list of person. List person, I'll call this people. And we can set that equal to a new list of person. I like that. I need to import that at all. Cannot be found. There we go. So I had to import our list from the generic collection. So then we can go ahead and say people.add, and I can move this down here. Let's create a space. I could do this, and I could add these people in by variable name, or I can actually just take a new person and instantiate it inside of that method, because people.add takes a type of person, because we said it's a list of person. New person, this constructor, returns a person. So the return type matches the parameter type right there, person item of that. So it returns a person into our add. So we could follow that same pattern there and say people.add. Take this one now, paste that in there. There's our people. Now these don't make sense anymore because person 1 and person 2 are no longer variables that exist. So we'd have to do something like people dot get people dot people 0 and people 1. All right, so that's how we could call it. So let's make sure this is working here. There we go. We got both of our people being printed out. They're stored in a list. Now the next thing we could do to refactor this to make this a little better would be to put this inside of a loop instead of writing out this line for each person. Because right now we only have 2, not a big deal. But say we had 1,000 or an unknown amount. We don't know how many people there are in our people list. Well, then we want to loop over it, right? So we can use a for each loop. So for each person, I'm going to call it person, in people. So the way the for each loop works, as a refresher, is that it basically takes 2 parameters. First one is the alias you want to give each element of that collection. So we're looping through people, which is this list up here. Inside of this block, we want to perform some code, some operations on each element in the people list. To refer to that element within this block, we're going to call it person. I could call that X, I could call that peanut butter, call it whatever I want to, just so you know. But person is a name that's better. You also have to give it its type. It is going to be a person type. I'll call it lowercase person. So for each person in people, let's do this. We're going to say person dot describe. Now I can remove these, run that. Same output. So we've got this, and that's nice. Now say we start adding more people, and we have to keep track of them. And we want to group people together into different groups or teams. Well, that team could have a few different attributes, such as the team name. It could have one of the properties or the fields on the team would be a list of people. We basically move this structure right here, or a list of person, to the team class. We might also have something like describe team, which would go through and describe everybody in the team, print out the name of the team, print out the information for each person. We could have something like get count. It returns, or not get count, number of people in the team, get number of people, something like that. So let's go ahead and create another class now. Add new item. We'll call this a team. So in our team, we'll start out with a private string name, here we'll add private int average age. That'll be something fun we can program there. And then we will have our private list of person, and this list of person will be called members, because each member of the team. And we have to set that equal to a new list. Before we can add anything to it, we have to actually point this members variable at an object in memory. That is what this part does. Anytime you use the new keyword, you are creating an object in memory. The assignment operator will assign that object in memory to the variable, or rather the variable to point at that object in memory. So we've got new list of person, and our brackets, or our parentheses to instantiate that. So we'll go ahead and create our constructor here. And the constructor, remember, it's just public and then the name of the class. We only want the name to be set from the start. The average age will be calculated based on when someone's added or removed, and then the list is already set to a new list, so we don't need that. So just name. So this dot name equals name. Good. Now we do need a way to interact with the list, or our members object up here. So let's go ahead and add public. We'll make it void. Call it add member. Add member will take a type person. We'll call it lowercase person here. This is a convention you'll see used a lot, where you have the type and then just the lowercase version of the type. So it takes person, and then it will say members.add person. There we go. We can now interact with it, with a team, and add a person to it. So let's go ahead and add one last thing, because we want to be able to see that we're doing something. Let's go public void describe team. So I'll just leave it as describe. So first we want to console.writeLine team name. It is that. And then we'll do that same for each loop. So I could copy it, but I'm going to write it out so we just get more practice. So for each person, and I'm going to call it member here because the context, each person is a member here. That's just naming convention. It has nothing to do with the code. Again, I could name it X or peanut butter. I'm just going to call it member, because I'm going to say for each member in my members list. In members, we'll go ahead and call member.describe. So now I've written all this code, and all this code, when I run this, doesn't change anything. Nothing's happening. None of these are actually lines of code that do anything. It's just setting up functionality that can be used. So when I come back to my program, I can go ahead and create a new team. So let's go team, my team equals new team. Now remember, it wants a name, so I'm going to call this the A team. And then I want to add some people to this team. Because right now, actually, let me remove all this for a second. Right now, if I call my team.describe And if you can guess what it'll print out, then that's good in your head. See if you can guess. Prints out the team name. So I want to add some people to this. So let's go ahead and say my team dot add member. Let's add this member. So I'm going to move that again up to here. It takes a person, so anything that returns a person can go there. And we already know that the new keyword will return the type that you're creating. So that returns a person. Let's put that in there. So my team, add member. Need another person. Grab this person right here. Now I can get rid of all of this. Well, I don't want to get rid of my team. You can put it back. My team dot describe. Let's see what we get here. There we go. Team name, a team. There's the members. You can always mess with this to make it look better. Say I want team name, and then I want right line. Let's put a block under it. And then we can run that. And actually, I'm just being picky. I want that instead. That looks better to me. Now we can run it, and you can see the change that it makes. Now we've got our person class that we created. We got our team class that we created. You can see that average age is underlined green. And what does it say if you hover over that? The field average age is never used. We haven't done anything with it yet. So let's add a method in there that will do something for that. Now this is going to be a private method. And so I'm going to keep it here. So private, this will be void as well. And this will be calculate average age. So what this is going to do is it's going to set average age equal to the, well, obviously average age of all the members. So what we want to do is set the average age. Let's see here. There's a whole bunch of different ways we could program this. I'm going to go a less efficient way just so it's all the way spelled out instead of having some implicit things. So let's go ahead and set int average. Average like that. There we go. Int average equals 0 to start. Now we'll go ahead and say for each, this should be looking very familiar by now. For each person, member in members, we want to sum up everything first, right? So let's say average plus equals, which is the same thing as saying average equals average plus. So average is equal to average, what it currently is, plus member dot, oh, you know what? I don't have a way to access that data because it's private, right? So I can come back in here and I can create a getter for that. So let's create a prop. There's different ways to do getters, and C# likes, people like a specific way. So actually what I'm going to do here, I'm going to make this public, and I'm going to add my getter and setter. So get, actually I'm just going to add a getter. I do not want a setter. So I can just get it like that. There we go. So member dot age, now I have access to it. So once I've added it all together, in order to get the average, I need to say average, or rather we'll say this dot average age equals our average divided by members dot count. That should give us our average. So with our average age, we can use it here. We'll say team name, console.write line, average age plus average age. All right, let's see if this works here. Average age is 0, so that's not correct. So let's see what we did wrong. So int average age equals that plus member.age. Average age equals average divided by members.count. All right, this is a good time to do some debugging. Actually, oh wait, no, we never calculate the average, do we? So we don't ever calculate the average. So what we need to do is every time we add a member, we'll go ahead and recalculate it. So after we add the member, we will call calculate average age right there. So whenever, I just said it, I'm going to say it again. Whenever we add a member, the age will be calculated. Now this is a private method, so it can only be called within our class. If I try to go outside the class and say my team.count, it's not there. You do not have access to it. So that's a big difference between public and private. Public means it's accessible outside the class. So here I'm in main, I'm not in that class. I can access public methods. I cannot access private. Private are only accessible inside the class, like here. I can call it. So let's see what happens now when we run it. There we go, we got an average age. That's better. That makes sense, 29.33, average is 31. Now let's go ahead. We've got some stuff working here. Let's make it a little more interactive, something that a user can actually use. So in order to do that, I want to make a console application that it's menu driven. So there's options on the menu, and these options allow you to manage a team. So let's say, let's get rid of all this. We're going to start with, well, first let's think about it. If we have a menu-driven program, and so it says like choose an option 1, 2, or 3. Each one does something different. Like 1 will describe the team, 2 will add a new member to the team, and then 3 is exit. So end the application. Well, if I choose 2 and I add a new member, and then it goes back to the top and it says choose a new, choose an option again, and it keeps doing that until I put in the command to exit. What are we going to be using? That's going to be a loop, right? When you're thinking about that logically, you have to loop over, you have to perform this set of actions over and over and over until something is true. So in order for it to be until something is true, we need a way to, we need a variable to store that, right? So let's go ahead and say string selection, it's a good name for whatever the user selects, equals console.readLine. So console.readLine will return the user input, so then we can interact with it and use the user input. So just to show a quick example, I can then go console.writeLine hello plus selection. And just to be a little more thorough, console.writeLine. Actually, we'll do console.write here. Please enter your name. For those of you who do not know the difference between WriteLine and write, the difference is write will just print out some text and it will not have a new line character. It won't drop you down to a new line. And WriteLine will drop you down to a new line. I'll show you what I mean here. So this first one is using write, And see how the cursor is still there? So if I start writing, it stays there. Write line actually returns to the next line. So that's how we can, using console read line, we can get user input and then use it how we want to. So that'll be a big part of this. So getting rid of some things here now. Let's go ahead and show a menu. Console.WriteLine. Please select one of, spell one correctly, one of the following options. Let's put console.WriteLine. I'm going to go ahead and copy this so I can just paste it from now on. Please select from one of the following. Add a little bar there to make it look nicer. All right, option one will be to describe team. Option two will be to add new member. And option three, oh yeah, I copied that, could have just pasted it. Option three will be to exit application. There we go. So right now it'll print this stuff out and then it will read our selection. So what we need to do is create a loop here. Let's say while selection does not equal 3, right? Because 3 is exit. So while it equals anything but 3, then we want to keep looping. And there we go. Keep looping. Actually, what I want to do is I want to move this all into here. We will X that out. Just set it equal to blank for now because that doesn't equal 3, so it allows us to iterate. And then I'll put selection equals console.readline. So that will happen inside the loop, which is good. Now what we can do is determine what was selected. So let's go ahead and say, let's use a switch here. Switch, what are we looking at? We're looking at our selection variable. And if, we'll use the case, if the case is 1, did I do that wrong? If the case is 1, then console.WriteLine. Let's get back up here. Console.WriteLine. You selected to describe. Actually, we don't even need to do that. We can just, we can add the team. We're going to go ahead and create a new team up here. So we got team, my team equals new team. That needs a name, a team. Right, case 1. Let's go ahead and my team dot describe. There we go. And break. Is it supposed to have the colon there? There we go. Now we've got case 2. is add a new member. So we'll add that in a minute. Let's just add a console.writeLine for now, showing that adding new member. All right, and then we will break. And then case 3, that doesn't do anything because it's just going to, now we can have it print out something. So case 3, console.writeLine, exiting. And then we can add a default here. Console.writeLine. Please select a valid option. Break. There we go. There's our select. So let's see if I run this, what happens right now. See what I'm missing here. So please select one of the following options. If I type in 1, it actually prints out the team. Team A, average 0 because there's no one added to it yet, right? Then it brings me back to my options. If I click 2, it says adding a new member, which is nice because that's what it's supposed to say, and then it loops back to this. If I click 4, it says please select a valid option. If I do 3, exiting, application exits. So that's how you can build a menu-driven application via the console. But now what we want to add is actually the ability to add a member. And actually after each one of these, I want to write console.writeLine so it looks a little cleaner instead of just being right on top of each other. So do that. Do that. Do that. All right, so we need to add a new member. So to do this, instead of writing all the code right there, I'm going to make a helper method. So outside of my main method, I'm going to go ahead and create private. This will be, it's going to return a person because that's what we're creating. So we want to return a person and add it to the team. So person, we'll call this, we'll call this create person. And we'll make this static. It has to be static in order to be called inside of that method. So let's say person equals new person. Now that needs a name and an age. So let's get the name and the age from the user. So let's say string name equals console.readLine. And then we can go int age equals, again, those can be any name we want. Age and name work for this. Makes sense. Console.readLine. Now it's going to give us an error here because cannot implicitly convert type string to int. So let's see if I can remember int 32.parse. So we're going to try to parse this string that comes back from console.readLine into an integer, and then we can assign it to int. Now we can go ahead and we can add name and age. Now we've got a person. This is still red because we need to return the person. Not all code paths return a value. Because we said it needs to return a person, we have to follow that and return a person. There we go. So instead of having this console.writeLine adding a new member, we can now say my team.addMember, and we will call create person. So it'll start reading it on runtime. It will get to here, add member. I'll say create person. It will jump down to here. It will do this, and then it will return that person, which will get added to our team. Now, if I run this right now, I don't have anything prompting the user to enter a name. So I might know how to do it because I'm the one who programmed it, but we usually don't program for ourselves. Not all the time. I mean, I build tools for myself, but usually you want to give users some instruction. So we should probably say console.writeLine up here. Actually, do I still have that? Cool. Console.writeLine. And actually, I'm going to make it right. Enter member name. And then it will read that. And we'll add console.write. Enter member, not if I can spell, age. There we go. So let's see how this works now. So if I click describe team, there's nothing there except for the name of the team which was created there. Let's go ahead and add a member. Enter name, Tom. Enter age, 12. Now if I hit describe team, I get average age is 12, and I get Tom is 12 years old. Let's try to add a new member, Sally, and her age is 41. And let's describe the team again. Average age is 26. So now I have an application that allows me to add members to it. Obviously, it's not connected to a database. That's something you could do later on. But I have a menu-driven application that is object-oriented. We've got our objects. Our data is encapsulated. So at this point, you should be able to go out and program any type of console application you want. Menu-driven console application. I'll hit 3 to exit. It says exiting. Hit enter. There we go. You could always go back and make it more robust, add maybe first name and last name to person, add whatever else you want. You could add different types of collections. You don't just have to have teams. But yeah, that's pretty much it for this. I'll go ahead and open up for questions now. Does anyone have any questions?
It's all recorded. Will be posted up later.
Say that again.
This is all recorded, so you'll be posting this up later.
Yes, this is recorded and it will get posted.
Right on. Cool. Thank you.
All right. So if there's no other questions, we'll go ahead and end this meeting lecture, and then I will get this posted as soon as it saves to my computer. So thanks for joining, everyone. Have a good night.
Thanks, Nick.